integration in logical learning.
Today our lesson is solid, liquid and gases. Matter. The matter is made up of very tiny particles, and these particles are so small that we cannot see them with naked eyes. It has been observed that matter exists in nature in different forms. Some substances are rigid and have a fixed shape like wood and stone. Some substances can flow and take the shape of their container like water, while there are forms of matter that do not have definite shape or size, such as air. Thus, the matter can be classified into different categories based on the physical properties exhibited by them and the states in which they exist. These are called states of matter. These are some pictures of three states of matter in the following: solid, liquid and gas. So following are the basic three states of matter: solid, liquid, gas. Solid definition. In solids, particles are tightly or closely packed. The gaps between the particles are tiny and hence it is tough to compress them. Solid has a fixed shape and volume. Due to its rigid nature, particles in solid can only vibrate about their mean position and cannot move. Force of attraction between particles is adamant. The rate of diffusion in solids is very low. An example of solids: solid ice, sugar, rock, wood, etc. Liquid. In a liquid state of matter, particles are less tightly packed as compared to solids. Liquids take the shape of the container in which they are kept. Liquids are difficult to compress as particles have less space between them to move. Liquids have fixed volume but no fixed shape. The rate of diffusion in liquids is higher than that of solids. Force of attraction between the particles is weak than solids. Example of liquid state of matter: water, milk, blood, coffee, etc. Gas. In gases, particles are far apart from each other. Force of attraction between the particles is negligible and they can move freely. Gases have neither a fixed volume nor a fixed shape. The gaseous state has the highest compressibility as compared to solids and liquids. The rate of diffusion is higher than solids and liquids. The kinetic energy of particles is higher than in solids and liquids. An example of gases: air, helium, nitrogen, oxygen, carbon dioxide, etc. Changes between liquids and solids. Freezing. Heat transfer occurs between the warmer tray and the colder air in the freezer. The warm water loses heat to the cold air in the freezer. This heat transfer occurs until no energy is available for the particles to slide past each other. This forces them to remain in fixed positions, locked in place by the force of attraction between them. This was liquid water is changed into solid ice. The process of liquid water changing to solid ice is termed as freezing. The temperature at which it occurs is known as freezing point. Melting. If you took out the ice cubes from the freezer and placed them in a warm room, the ice would absorb energy from the warmer air around them. This absorbed energy would facilitate them to overcome the force of attraction holding them together, enabling them to slip out of the fixed position that they held as ice. The process in which a solid is changed to a liquid is called melting. The melting point is the temperature at which a solid changes to a liquid. Changes between liquids and gases. Vaporization. If the water is hot enough, it starts to boil. Bubbles of water vapor are formed in the boiling water. This happens as particles of liquid water gain enough energy to completely overcome the force of attraction between them and change to the gaseous state. The bubbles rise through the water and escape from the pot as steam. The process in which a liquid boils and changes to a gas is called vaporization. The temperature at which a liquid boils in its boiling point. Changes between solids and gases. Sublimation. The process in which solids directly change to gases is known as sublimation. This occurs when solid absorbs enough energy to completely overcome the force of attraction between them. Dry ice is an example of solids that undergo sublimation. Hopefully you have loved this video. Stay tuned with us. Thank you for watching.